Okay, here we go, 35. Now, one thing I do frequently is I look at a problem and then I change the problem. Because I'm trying to prepare you not for this problem, but for who knows what. So we're going to not work this problem right now. We're going to change the problem and just have a little discussion to make sure we're understanding some big ideas. So we're going to take away the problem here for a minute, magically. Okay, so no problem for a minute. We also want to change that. We don't want to call this f prime right now. So we can get rid of that. We're trying to learn a couple of concepts here. So we're going to call this for now f. So we are not doing the problem that's on the sheet. We're doing something else to illustrate a key idea. Okay? And the key idea we're working on is on your reference sheet. Your reference sheet has at the very top a box and has some definitions. One of those definitions is any function has a relative max. This is a relative or local max when that function changes increase to decrease. So any function has a relative max when that function changes increase to decrease. I'm going to come back here and type. I'm going to put some letters on here. Oh, we've got enough. We're good. So you might encounter a question on the test that asks exactly that. Like that's realistic. They give you some function like this. They call it f. Mouse to work.
Upper right corner.
Can't get it to move somehow. It's not communicating. Out of range. Hold on. Can't go here. Pretty good. Deep stages would be very helpful. Learn about the packet. So, where's Sam? Okay, now we mouse to work. There we go. Okay. So what we want to type is this. F of x has a relative max at x equal. Look at your reference sheet again. The reference sheet says any function. So right now we're using f as our any function. Any function has a relative max when that function changes increase to decrease. So raise your hand if you can tell me where does f have a relative max. Looking for hands. What about half of you? Let's go Lincoln in the back.
Would it be J? Where it's J on the...
Right here, J.
Yeah.
Close. Let me do something up. That's not what I wanted. You dumb machine. Try again. What you just found was a relative min. So f of x has a relative min at x equal j because f of x changes decrease to increase at x equal j. 2 points if you had your hand raised. Anyone want to talk about that? Why does it keep doing that? Oh, I know why. Silly me. It's underneath the text.
Here we go today.
So f has a relative min when at x equal j because f changes decrease to increase at x equal j. Let's go erase this again. Trying with the mouse, not my strongest talent, but and then this is not f, this is not double prime, we're just saying this is f. Questions? So it ends up, where does f have a relative max? Ends up, oh, Hands down again, sorry. Does F have any other relative min? Hands up. Does F have more than one relative min? Man, why have all these whiteouts? I'm in trouble. So, Sam Hansen, what do you say? B. So at x equal b, same thing. So I can go here and say at x equal j and x equal b. 2 points if you knew that. Because f changes decrease to increase at x equal j and x equal b. Relative max is just the opposite. Are you comfortable? Okay. Now what we're going to do is what is more likely to happen on the test, which is they'll say this is not f. They'll say this is f prime. Okay? And they'll ask you, you won't be able to see f. You don't see the graph of f. You just see the graph of f prime. So this is f prime. They're going to ask you to identify, does the unseen graph of f have a relative, we'll say min in this case, just matching up. So they're going to ask if the graph of f has a relative min. Okay, so you have to use Danica's chart for that. You don't have to, but I find it very useful. If we're looking for a relative min on f, we're looking to see what we saw here. When f changes decrease to increase, decrease to increase. There's a typo in your reference sheet. You should probably fix that right now. Next to concave down, it's supposed to be a D. Maybe you already fixed that. Yeah, we did. Okay, so we're good. Anyway, back to relative min. I'm looking for when f changes decrease to increase. That's going to happen when I can see f prime changing negative to positive. Because f prime is the slope of f. So when f prime is negative, f's going down. When f prime is positive, f's going back up. So if this is a graph of f prime, and they ask me to identify where f has a relative max, this is how I do it. I type f has a relative min, at some x coordinate, blank, because f prime of x changes negative to positive at x equal whatever x that is. So we've done two different problems now. We pretended this was f, in which case this would have been the answer where f has a relative min. This one here. We then changed the graph to f prime, and are now saying, okay, if this is f prime, where would the unseen graph of f have a relative max? Who knows the answer? Hands up. Where would the unseen graph of f have a relative max? Relative min. Keep switching that. So I fooled about half of you somehow. The definition is f has a relative min when f prime changes negative to positive, because that would be f changing decrease to increase. So this is f prime now. Where will this f prime graph change negative to positive? That means the y values of f prime change negative to positive. Hands up again. Who knows? A bit better. Let's go, Ruby.
Is it 0?
So at x equals 0, we see the y values of f prime changing from negative to positive. Therefore, f itself will change decrease to increase at that same x coordinate. So that's why it's saying that f has a relative min at x equals 0, because f prime changes negative to positive at x equals 0. 2 points if your hand was raised. Let's go to your reference sheet again here. Let's look at something. Maybe this will help. Sorry, Sam. So back on the reference sheet, way back at the beginning here, what I'm trying to point out is this. Okay. this little box says right here that F has a relative max. Okay. F has a relative max at x equal 1.25. So that's right here. F is the blue. So right here you can see F changing from increase to decrease. But exactly at the moment when F changes increase to decrease, F prime is changing positive to negative. The orange is F prime. So here's F prime changing from positive y values to negative y values. That's what I was trying to illustrate on that other graph. That you can look at F prime and figure out when F changes increase to decrease by just looking at F prime. Questions? Cool. So back to the one we were on. I'll just stay here for a second. Another definition on your reference sheet is inflection point. That's up here. Since a function has an inflection point, when that function changes concavity. So if we look at the blue again, the blue is concave up all the way to right there. Then the blue switches to concave down, like so. But Danica's chart up here helps me identify the fact that when F is changing concavity, concave up to concave down, F prime is going to change increase to decrease. So on the test, you'll be asked to look at a graph of F prime, the orange, and note, hey look, F prime is increasing. Right there, F prime changes to decrease. So I could look at F prime and figure out when F has an inflection point. You could also look at F double prime and see when F double prime changes positive to negative. That's the red one. Here's F double prime changing from positive to negative at exactly the same point. So that's how you can identify an inflection point. Ava, please.
With the increase and decrease, you said, is that positive or negative? Does that mean if it's increasing, does that mean the graph will be positive or have a positive slope?
So it all depends on which thing we're talking about, which is why it can be confusing for sure. So pick something more specific and I'll talk about it again. Say it again, Ava. Roughly, like you were looking at an inflection point, or were you looking at relative min? Were you looking at relative min? Okay. So to talk about it in a way that won't get really confusing, we first have to identify, do you want me to talk about the relative min of F, F prime, or F double prime? Because they all actually have, each of those has a relative min in this picture, but each of those, the relative min of each of those is in a different place. So which one do you want me to talk about? F double prime. If you're looking for the relative min of F double prime, what you have to look for is when F double prime changes from decrease to increase. That's the definition. This means the y values of F double prime are going to be going down, and then they'll switch and they'll start going up. So everyone, answer this question. Great test prep. Does F double prime, which is the red graph, have a relative min? This is the definition. Hands up. Does F prime have a relative min? And if yes, where? Hands up. Does F prime have a relative min, Olivia?
Like where is it? Or
Yeah, where would it be?
1.750.
So Olivia correctly used the definition, 2 points if you all knew. She said, hey, on F double prime, at this time right here, F double prime is switching from y values that go down to y values that go up. That's 100% accurate. That's where F double prime would have a relative min. Now, you're probably not answering Ava's question, but we're going to keep going for a second. If you do the relative min on F prime, Hands up. Who knows where f prime has a relative min? Hands up. Where does f prime have a relative min? F prime is the orange. Where does f prime have a relative min? There we go. Get a few more. Still waiting. Where does f prime have a relative min? Let's go over to Jared.
Is it 2.931?
So here's where f prime has a relative min, 2.931. How many knew that? Two more. That's where f prime is switching decrease to increase. But on the test, what they usually do is they ask you to identify something from a graph you cannot see. So a more common question is going to be, look at f prime.
So if I look at 3, that has factors of 1 and 3.
I should say, look at, come on board. Like, look at f double prime.
The biggest number they both have in common is 3. The biggest common factor they have is 3.
Come
So what
on.
I'm going
Look
to
at f double prime and figure out where f prime has a relative min. And the way you do that is you say, okay, I'm looking for the relative min on f prime, which means I need a decrease to increase change. That's going to be on f double prime a negative to positive change. So right here, where f prime has a relative min, you will see the y values of f double prime changing from being negative to being positive. That's how you can look at f double prime and figure out where f prime has a relative min. That's the idea.
So we're going to multiply, but
Please.
we're dividing by.
How can you tell where f of x has a relative min or max from f double prime?
Oh, awesome. You can't. Two more for Lennox. That's why these are blank, because there is no definitive connection between the two. So I can't. Good question. Anybody else? Yeah, all the way back to 35 then. Okay, we're going to go ahead and answer the actual question now. Got some practice with that. Okay, it says the second derivative of the function f is given by this equation. I don't stop to read the equation because I don't really need it. I have a picture of f double prime right there. For what values of x will the graph of f have a point of inflection? So your reference sheet says any function has a point of inflection when that function changes concavity. We are looking for when f has a point of inflection. So we're trying to figure out when f does this. We want to see when f changes concavity, like this. But we are trying to do it by looking at f prime, f double prime. So f double prime does something different. When f double prime changes like this, that's when f has an inflection point. I'm going to go all the way back to the reference sheet again. Sorry for all this jumping around.
If I broke 18 down into, let's say,
You can see it on the reference sheet right here. The blue graph is changing concavity. Concave up to concave down. At exactly the same spot where the f double prime changed from positive y values to negative y values. So that's what we're looking for on number 35, because we're looking at f double prime, trying to figure out what the unseen graph of f will look like. So back on 35, raise your hand please if you can answer the question. If you're looking at f double prime, is there a x-coordinate where the unseen graph of f will change concavity based on this graph of f double prime? Hands. That's better. Most everybody. Hoping for a couple more. Let's go take. A and 0. So if I go to x equal a, F double prime is changing from positive values to negative. That means if I were looking at the graph of F, which I can't see, but if I were looking at the graph of F, 2 points if your hand was raised, I would see at x equal a, F would be, just before, back up here, what I would see is that just before x equal a, f of x would be concave up. Then just after x equal a, f of x would be concave down. Because just before x equal a, f double prime is positive, and then f double prime is 0, and then after f double prime is negative. So Tate's correct. X equal a is definitely a spot where f would change concavity. Something very similar happens here at x equals 0. At x equals 0, we've got f double prime is equal to 0. Just prior to that, f would have been concave down. This would have been negative. Just after that, f is concave up. This would have been positive. So the correct answer is 0 and a only. We want to talk about any of those. Yeah, please, Seth.
I was just wondering, so what makes it an inflection on this one? Like, what makes is it just like positive and then 0 and negative? Is that what makes it an inflection?
So you're on the right path, but what you've got to do is add a few more words to what you're thinking. Because the tricky part is this. All eyes up here and look up. Here's the tricky part. You're asked to deal with f, f prime, and f double prime. And so you've got to make sure we identify, we're talking about an inflection point on which one. So are you asking about an inflection point on f, f prime, or f double prime?
F double prime.
So if I'm looking at f double prime, 2 for Sam, and I want the inflection point on f double prime, that's a different analysis. What I'm going to do then is I'm going to pay attention to the concavity of f double prime. And I'm going to say, okay, when f double prime changes, I'm looking at the definition. When f double prime changes, concave up to concave down or vice versa, that will be an inflection point on f double prime. So here's f double prime being concave up. Right about there, f double prime changes to concave down. So we get to about here. Then f double prime changes back to concave up. So f double prime has inflection points at x equals 0 and x equal m. So f double prime has inflection points at different x coordinates than f, because they're two different graphs. But what we are learning is that f double prime can do something else, and that will tell you what, where the inflection point on f was. If you're trying to identify the inflection point on f double prime, you're not looking at this, you're looking at this. You want to see f double prime changing concavity. Can't tell if that helped though.
Yeah.
Okay, 2 more, please.
So I get how we would go from f double prime to f just in general, but what about f double prime to just f prime? It feels like we're kind of skipping a step.
Would depend on what they're asking again. So just make up anything you want. What questions you want?
They're asking same question except just replacing f with f prime.
So they're saying, where does f prime have an inflection point?
Yeah.
Perfect. So f prime has an inflection point. Okay, I start out my thinking exactly like I did here, Ashton. F prime would have an inflection point when f prime does this. that's an inflection point on f prime. Okay with that? But again, we're not looking at f prime, so we can't use that. So we come over here and say, oh, but look at the correspondence. When f prime is changing like this, f double prime is changing like this.
Okay.
So I'd say, okay, right here at J, f double prime changed from decrease to increase. That means on the unseen graph of f prime, there would be an inflection point. Like that. Same would happen at K and also B. So the inflection points that are happening on f double prime are different than the inflection points that are happening on f prime. But I can use f double prime to identify where f has an inflection point.
Okay, makes sense. I was just a little lost. I didn't see the bottom half of
Oh,
that on
yeah, just keep asking. Two more. Please look at it.
Wait, sorry, I'm just confused by the chart. So are you saying like, in general, when it's concave up, it's positive for f double prime, or is it like showing it on that graph?
So what the chart is telling you is how the three different graphs correspond to each other.
Sorry,
Oh,
the
sorry.
chart
Over here. Gotcha, my bad. Keep saying it again, Olivia.
I'm just like, does it relate to the graph, or is it just like showing in general?
Awesome. So this chart does relate to this graph specifically, and here's how. I don't see f. There's no picture of f. But I do know how f relates to f prime and f double prime. I know that right here, these are values of f double prime. What's true about all of these values right here of f double prime, Olivia?
Positive?
Perfect. So that's what I wrote over here. As I said, if we're before x equal a up here, all of our f double prime values are positive. Good with that? That means if we had a picture of f itself, which we don't, you would see a concave up shape to f for all x's that are more negative than x equal a. Good with that? But then these y values here, what's true about all of these, Olivia?
Negative.
Those are all negative. That means from x equal a all the way to x equals 0, x equal a all the way to x equals 0, all the values of f double prime are negative, like what you see here. Good with that? That means on the unseen graph of f, we would see a shape that is only concave down. So if I could see the graph of f from x equal a to x equals 0, f would only be concave down in that space. That's what this table is telling you. Can't tell if that helped at all, though.
But like, where does the graph of f? Like, it's
So,
just,
say it louder, sorry.
like, I'm just like, where does it? I don't know. Is it just like?
So the idea is this. Back on the reference sheet, two more, keep track, I'm going to keep giving you points, seriously. Like, your questions are exactly what you need to do. Two more for Olivia. So look over here. So here's what they're going to test you on the test. They're going to say there was a graph that was blue, that was f. Where it comes from, we don't really worry about yet. Just, we have a graph. And then if we measure the slope of that graph at every point, and we write down those slopes, we can create another graph. That's f prime. Comfortable? And then if we measure the slopes of that second graph, we can get another graph, which is f double prime. Now what they'll do in a question is they'll erase two of the three. So the one you're looking at, 35, they have erased f and they've erased f prime. They were there because that's where they got f double prime. You okay with that?
So this is f double prime.
So yeah, there's an indicator on it. No, you're good. There's a label on it.
Oh, okay.
No worries, just keep asking. So Olivia, mark down 2 more, seriously, mark down 2 more. Hey, look, what you're doing is what you have to do. Like, if it doesn't make sense, you just talk.
Okay.
Good so far? Okay, so they've erased the blue and the orange,
Yeah.
and you're only looking at the red. But they're asking you to figure out, when did the concavity of the blue change? So you're coming back here and saying, I can't see this. Like, I can't see the concave. So here's the blue, concave up. And now the blue is going to be concave down. I can't see that. But Danica's chart tells me what I need. It says, hey, when F did this, F double prime did this. So on number 35, I'm just looking to see when F double prime changes from positive to negative. That tells me when the graph I can't see changed concavity. That did seem to help.
Yeah.
Mark down 2 more, seriously. Don't stop marking. Question. Okay, cool. Stop that video.